Standing proud off the coast of Dubai is one of the most incredible buildings on the planet. At 321 meters, it soars higher than the Eiffel Tower. It's the tallest hotel on Earth and possibly the most luxurious. A structure designed to amaze. Its name means the Arabian Tower. This is the Burj Al Arab. But creating this 21st century icon will be an epic struggle that pushes everyone involved to the limit. In November 1994, construction begins on what is planned as the world's tallest and most luxurious hotel. The pressure is on from day one. With the eyes of the world watching, no one on the project will want to disappoint this particular client. Sheikh Mohammed bin Rashid Al Maktoum, Dubai's crown prince, is the visionary behind this amazing building. The project is his response to the economic time bomb his country confronts. As his close advisor, Sultan bin Sulayem knows all too well.
He knew that we don't have oil. He knows that oil is going to end someday. And they have two choices. Either go and do something about it and find other alternative ways to sustain the life for the people of Dubai, or sit waiting for help.
Only 50 years ago, Dubai's a dusty backwater, home to pearl divers, coastal traders and Bedouin. Then, in the 1960s, prospectors discover oil. The sudden injection of millions of petrodollars transforms the sheikhdom. But geologists predict the oil boom will be over by 2016. The good life could end just as quickly as it began, when the wells run dry. The answer to Dubai's economic survival lies in its geography. This tiny emirate, less than twice the size of London, is in the remote Arabian Gulf. But Dubai has three untapped assets: sun, sand, and sea. Facing future economic meltdown, Sheikh Mohammed makes a crucial decision. He will turn his country into one of the world's most exclusive holiday destinations, a playground for the rich on the Arabian Gulf Coast. The Sheikh needs a luxurious centerpiece to launch his country into high-end tourism. He stakes what some speculate is over $1 billion on the tallest, most lavish hotel in the world, with a unique 7-star reputation, the Burj Al Arab.
I think it was very important to put Dubai on the map of the world. There's no hotel like this hotel. It takes guts, and Sheikh Mohammed has a lot of guts.
The Sheikh's courage is clear from his choice of architects. A radical young team from Britain, brave enough to take up the challenge, but very short on experience. They are led by Chief Architect Tom Wright.
We had an average age of 32.
Not a grey hair between us.
And none of us had gone over about 15 stories.
I was quite staggered by the scale and the immensity of the project.
Tom Wright and his colleagues have a reputation for innovative engineering, but they're more used to designing schools and offices. But Dubai is a place where connections can make all the difference. Through a contact in the ruler's office, the team gets its break. Sheikh Mohammed agrees to a meeting and is so impressed with their initial concepts, he awards them the contract. Now Wright must turn his sketches into a design so remarkable, the building becomes a world-renowned landmark.
We had many sleepless nights worrying that the building we'd designed wouldn't turn out to be at all iconic.
Wright knows he must push his design to the limits. A building only becomes an icon when its form is simple but unique.
We decided that if you could draw a building simply with a few strokes of a pen, And it was instantly recognizable as not only the building, but the place, Egypt in this case. You'd created something that was iconic. So if you consider these buildings in the world, there are probably no more than 10 maximum that have actually achieved this status. Australia, Sydney Opera House. As with all these buildings, it's usually just the first couple of lines that actually make you know exactly where the building is. Paris. And you have to put a flag on the top.
Can Tom Wright and his team compete with the likes of Gustav Eiffel? This is a once-in-a-lifetime challenge. All the brainstorming pays off when Wright finally has his eureka moment.
We were sitting there having a beer, watching the modern sailing yacht come out of the Dubai Offshore Sailing Club. You think of excitement, you think of exhilaration, and we went, hey, this must be the one. The form we came up with is very simple, and within a few lines, I think you can see that it has all the elements of an iconic building. It's simple and instantly recognizable.
The concept immediately catches the Sheikh's imagination. A sail billowing in the wind has deep meaning for the people of Dubai with their seafaring heritage. To complete the nautical image, Wright wants the structure to rise out of the water like a massive yacht. But this will require an island as a base, and there are none. Wright's undeterred. He proposes they build an island specifically for the hotel, a first for Dubai. Constructing the hotel out at sea will significantly add to the risk and cost. Can Wright persuade his colleagues this radical scheme will work?
I remember I was pulling the sail out to sea, and the rest of the design team were pulling the sail back onto the shore. And this continued to go backwards and forwards before finally the client stepped in and said, no, it's going to be out at sea.
Sheikh Mohammed is prepared to take the risk. The hotel will be built 270 meters off the coast. No one has ever built a skyscraper this high on an artificial island. This 321-meter structure, weighing 250,000 tons, will need to stand firm against earthquakes and Gulf storms. Wright has won the first of many battles. The Burj will rise out of the sea. But time and again, his refusal to compromise will force his colleagues to push the boundaries of engineering to the limit. By early 1995, the construction team is hard at work on Phase 1, building a low-lying island. But the inexperienced architects are about to get a taste of Dubai's extreme weather. April the 27th, a powerful storm known as a shamal sweeps across the Gulf, hitting the coast with a vengeance. A set of construction barges lie in its path. Each is laden with 10,000 tons of rock. The architects have planned for all weather conditions, but the storm's intensity still shocks Simon Crisp.
We had 3 or 4 metre waves bashing onto the beach. To see the waves coming in like this was really quite a wake-up call for us.
One huge barge breaks loose and slams into the mainland. The team realizes the damage this kind of storm could inflict on their island hotel.
We had a really graphic example of how powerful the Gulf of Arabia can be when it's angry.
The architect's decision to expose their structure to these forces could have serious consequences. The engineers will have to struggle to produce a low-lying island capable of resisting nature's fury. The man-made island for the world's tallest hotel has hit a critical stage just 5 months into the build. Dubai's Sheikh Mohammed is depending on this project, the Burj Al Arab, to convert his country from oil producer to top-class tourist destination. But a debate rages over the island's height. Architect Tom Wright wants to make it low to give the impression of a sail rising out of the water.
We argued a lot about the height of the island. From a design point of view, I wanted people to be close to the sea.
From the start, he's gone head-to-head with engineer Mike McNicholas, who's responsible for the island's safety.
So I wanted the island as low as you possibly could, you know, skimming the sea. I'm coming from the other end, needed to make sure we were protecting the island.
McNicholas's worst fear is that waves breaking over the island could damage the hotel or even drag guests into the sea. Initially, the engineers planned to build the island using rocks. They are available locally and the technology is proven. But Wright rejects this. A rock island would have to be far too large to repel the sea safely. To keep the island low, McNicholas experiments with pioneering concrete blocks designed to reduce the impact of waves. But no one in the Gulf has ever used these blocks before.
I had to insist with the team that we carried out tank testing. It was the only way we were going to be sure that the island would be safe.
These tests replicate the power of the tallest waves that can occur once in 100 years and sends them crashing into a series of differently configured models. 3 weeks of testing prove the hollow blocks will work. The construction team builds the island with steep rock slopes, then covers them in concrete armor to absorb the force of the waves. These ingenious blocks work like a sponge. As the wave hits, the water passes inside the space and turns around on itself. The force is largely dissipated. With the engineers' help, architect Tom Wright has won his battle for a secure island that rises only 7.5 meters above the waves. Now the team begins the second stage of construction. In the center of the island, construction workers drive huge lengths of steel 20 meters into the ground. This creates a triangular steel wall known as a cofferdam, which will become the outside of the hotel basement once they excavate the sand from inside. But removing the sand could be dangerous.
That was a real challenge for us. It's sleepless day and nights, 7 days a week. How we were going to stop the seawater coming into the structure, how we were going to stop the seawater coming around our structure from beneath and flooding it.
The weight of the sea is a huge force on its bed. This pressure forces water through the sand and threatens to flood the artificial island from beneath. To keep the sea out, McNicholas injects liquid cement into the sand to seal off his steel wall from below. But as the sand is removed to form the basement, there's less and less weight to hold back the force of the sea. The cement seal is going to be tested to the limit.
In the worst case, the pressure caused by that water movement could have blown the whole bottom of the excavation like a champagne cork.
If McNicholas's calculations are wrong, the excavation could be swamped, killing hundreds of workers. But he stands by his design. With the cement seal in place, the excavators begin to remove the sand. As the man responsible, he's not going to let the workers face the risk alone.
I felt I had to be one of the first guys down at the bottom of the excavation, looking up 10 meters above myself, thinking each side of this cofferdam is 7,500 tons of sea pressure pushing in.
When put to the test, both wall and seal hold firm.
And one of the probably proudest moments of my career was being stood on that excavation and looking around and seeing the steel wall there surrounding me and thinking, we are holding back the sea. My design worked.
November 1995. The artificial island for the tallest all-suite hotel in the world is now complete. The construction team starts phase 3 of this one-off project, the foundations. The The support needed for any skyscraper is vast. But the location of the Burj Al Arab presents an added challenge.
It had never been done before to build something like this on reclaimed land. I mean, we're talking about a 300-metre high tower on a man-made island in 6 metres of the Arabian Gulf.
The problems multiply when the results of earlier core tests reveal bad news. The team searching for bedrock drilled deep into the seabed. But even a full 180 meters down, there was no solid rock. This will make their job tougher, but the architects remain defiant.
The average person would think we're crazy to build something like this on sand, let alone out in the water.
How will this 300-meter structure stand firm against earthquakes and winds of close to 150 kilometers an hour when its foundations depend on nothing more substantial than sand? On an artificial island 270 meters off the coast of Dubai, construction workers are preparing the ground for the tallest hotel in the world, the Burj Al Arab. But there's no bedrock beneath the site to support the foundations for a skyscraper. The architects have a plan. They want to support the Burj using steel-reinforced concrete foundation piles drilled deep into the sand. So, what's to stop the whole structure from just sinking? They are relying on an effect known as skin friction, the resistance that stops two rough surfaces slipping past each other.
Skin friction is all about the contact between the sand and the surface of the pile. And the longer the pile, the further in the ground it is, the greater that effect. And I'm going to demonstrate it now by whacking it in. You'll see it starts to move quite quickly with the first few impacts. Now it's starting to stiffen up a bit. Even though I'm not hitting it any harder or any softer, and the skin effect is starting to really kick in here.
Once the friction between the post and the sand around it equals the load of the hammer, the post comes to a halt. The crisp scheme will only anchor the Burj if the sand is compacted enough to create resistance around the building's piles. The drillers pack sand samples into sealed containers and send them off to be analyzed. If the results show the sand is too loose, then support on the piles anchoring the building could suddenly fail. The geography of Dubai gives everyone reason for concern. It lies within range of a major fault line, so this soaring megastructure could be vulnerable to earthquakes. In June 1964, a 7.5 magnitude earthquake hits Niigata in northern Japan. Because the area is built on sandy silt, the tremors flip over entire apartment buildings. This isn't normal earthquake collapse. It's a devastating phenomenon known as liquefaction. As grains of loose sand shake, they fill up any air pockets and compact, taking up less space. The ground stops behaving like solid earth and acts like a liquid. On shifting sand, any building could simply topple. When the results of the drilling tests return, it's good news. Deep beneath the site, they find compacted and calcified sand. Liquefaction is not a threat. But will the foundations be long enough for the skin friction to hold them firm?
We weren't going to take any chances, and we extended the piles by another 8 meters.
CRISP specifies foundations over 20% longer than originally planned. These 250 concrete piles have a combined length of 10 kilometers, 35 times as long as the towering hotel they will support. One by one, the engineers are solving the challenges thrown up by this extraordinary structure. But in 1996, They brace themselves for a new set of obstacles as Phase 4, the construction of the hotel itself, begins.
This building had to stand up to the worst that the Gulf could throw at it.
The hotel itself has slender concrete walls, not capable of withstanding the elements alone. To hold them firm against high winds and earthquakes, the architect devises a visually stunning solution. A gigantic steel structure outside the main building, known as an exoskeleton. A series of vast diagonal trusses tie two huge steel bows to the concrete core at the back of the building. Wright's design will make the building unique. But his giant diagonal trusses will make life hell for Anthony McCarter, the engineer who has to make them work.
Those trusses gave me 4 months of heartache, sleepless nights, worries, anxiety.
They must be incredibly strong to tie the exoskeleton together. But aesthetics are just as vital.
It was critical that these diagonals were very, very elegant and also very beautiful as they're so visible.
This building has to wow the world and make Dubai a must-stop destination. Wright's not about to compromise.
I used to go to Tom with option after option. I remember one particular occasion where I had 7 options and he went, no, 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 no good, no good, no good. It's the same angle, isn't it?
Eventually, McCarter finds a form that works structurally and is graceful enough to fit Wright's vision. But this in turn causes nightmares for Malcolm Murphy, the chief contractor.
It's okay for the architect to draw pretty pictures, but we have to build it.
He finds a factory just 15 kilometers from the construction site capable of welding the huge diagonals. Each one is longer than the Airbus A380 Super Jumbo and heavier than 20 double-decker buses. Welding these complex forms in the factory is the easy part. Transporting them to the site is not. With each truss weighing in at 165 tons and reaching a staggering 85 meters in length, it's no easy task.
And the challenge is to do that. It's just unbelievable.
No one has ever transported anything this size before in Dubai. But Murphy's not going to be beaten. He brings in one of the world's largest heavy lift transporters, a beast with a total of 80 wheels. It makes the slow journey to the construction site at an average speed of around 6 kilometers an hour. Police must close roads and remove traffic lights to allow this convoy through. When they finally reach the site, the contractors face their next hurdle. These 165-ton beasts have to be lifted into position.
The architect refuses point blank to position these things in 3 pieces, which we wanted to do originally. And he said, no, aesthetics, I'll not learn you to weld up there.
He has to find a way to lift the trusses in a single piece to a height of almost 200 meters, twice the height of the Statue of Liberty.
We had to go away and think of an idea how to actually lift these monsters up. We had 3 big monster cranes in there, and even they weren't big enough to lift the diagonal trusses.
Murphy must look further afield for a solution and brings in specialist lifting gear from Singapore. His team sets up winches, like those used on offshore drilling rigs, high on cantilever frames 15 meters from the building. Cables with a braking strength of 225 tons are attached to the end of the truss.
I can assure you we were very, very nervous that morning when we lifted the first one. 30, 40 guys had sleepless nights that week, getting ready for that first lift.
The 2 massive winches take up the strain and then painstakingly raise the diagonal truss little by little up the side of the building. It's all going to plan. Murphy and his team have solved the lifting dilemma. But these trusses have a sting in the tail. They need to fit into place with pinpoint accuracy. But Dubai's climate means temperatures can vary by as much as 14 degrees in a single day. And this will make the trusses expand and contract dramatically. The problem's known as thermal expansion.
The steerman's nightmare in the desert, working 50 degrees C.
Steel expands in the heat and contracts when cold.
Okay, chaps, light up. We're actually going to heat the steel up now, which is going to give you an idea of what temperatures we're working in the desert.
Heat makes the steel molecules move faster and further. And this 15-meter tube actually grows in length. The difference is visible.
What did I tell you? Steel does expand with the heat.
The diagonal trusses on the Burj Al Arab could expand and contract by a full 5 centimeters over a 24-hour period. They will never fit their precise point in the framework without an ingenious solution.
The engineers thought about it, the structural fabricators, the steel fabricators, the architects, everybody thought about it, and it was actually one of the architects came up with this great solution.
On the frame of the structure, the fixing bracket contains a vast washer with its hole offset from the center. This swivels until it lines up with the hole in the diagonal truss. Then, the cast steel pin, about 30 centimeters in diameter, is inserted through both holes, locking them together. This clever device buys the team the crucial 5 centimeters of play they require for the installation, and the truss is now fixed securely in place.
When we got that pin in, we had those champagne corks flying. It was just unbelievable.
But there's precious little time for celebration. The first VIP guests will arrive before the millennium. This leaves the team less than 36 months to complete the entire project.
Sheikh Mohammed's vision for the Burj Al Arab meant that it was needed yesterday.
January 1997. A colossus is emerging out of the Arabian Gulf. The Burj Al Arab is to be the tallest hotel in the world, the last word in luxury and a proud symbol for Dubai. Architect Tom Wright wants the building to be beautiful. The steel sections of the exoskeleton that will support it must be as minimal as possible. The view from these $2,000 a night suites will have to live up to the price tag.
When you're in the suite, looking through the windows, they are right in front of you, so they have to be exceptionally well detailed and well put together.
But this creates a dilemma. If Wright makes the exoskeleton too light, the wind's force at 300 meters above the Gulf could shake the building apart. Too bulky, and the elegant form of his yacht-shaped structure is ruined. Once again, Wright and the engineers, who must make his hotel safe, are on a collision course.
When you're designing a building that is taller than the Eiffel Tower, and you've never done one before, you want to make sure that you've got it right.
This structure is so unusual. For the first time in Dubai's history, engineers decide to do tests in a wind tunnel. Wind engineer Volker Butgereit knows the Burj Al Arab is one of a kind.
Before this building came along, most of the buildings in the Gulf were fairly orthodox shape. They were square, they were rectangular, they were nowhere near this scale. So doing a wind tunnel test for a building in those days in the Gulf was almost outrageous.
But for this extraordinary structure, it's essential. The wind tunnel simulates the wind effects of the Gulf around this 1:50 scale model.
This building has seen some pretty severe loads, almost twice what it would be seen in London. We measured suctions which were the order of a weight of a car hanging off, trying to suck the panel off the building. So that's quite something.
The wind tunnel throws up results that could threaten the entire exoskeleton.
When we first saw the design, there was immediate concern about vibration due to something called vortex shedding.
Vortex shedding is an engineer's nightmare. Certain wind conditions blowing over sharp edges on the steel structure can create miniature tornadoes. These set up dangerous vibrations that can shake a building to destruction. Which is exactly what happened to these massive cooling towers in Ferrybridge, Northern England in 1965. The engineers must find a way to protect the Burj Al Arab.
The simplest solution is to change the aerodynamic shape, but that upsets the architect.
The architectural idea of the exoskeleton structure is, when you look at it, the very essence of the building. If you take it off, it's just another building. If you put the exoskeleton structure on, you know, you have an icon.
The engineers need to think again.
This is classic vortex shedding.
We realized we had to come up with something clever that was not visible, but somehow reduced the motion.
They turn to an ingenious hanging weight called a tuned mass damper. These are installed at vulnerable points in the exoskeleton. When the wind blows and vortex shedding starts to create dangerous vibrations, the 5-ton weight will swing instead of the structure and damp down the vibrations to well within safety limits. 11 of these systems are fitted from the top of the 60-meter mast all the way down through each of the steel bow structures. These dampers safely cancel out the threat. June 1997. Dubai is reinventing itself as the luxury tourist destination. This old hotel bites the dust as the Burj Al Arab, the symbol of the new Dubai, approaches its final form. Just 30 months before the deadline, the crew begins constructing the toughest engineering challenge. Sheikh Mohammed wants the building to amaze, so the design calls for a restaurant that looks as if it's suspended in the sky.
I like the idea of the visitor sitting out in space, looking across the view towards the Arabian Gulf and Dubai, and sort of almost floating up in the clouds. The whole idea of hanging out over space would give you a dining experience pretty unparalleled.
The Al Muntaha, or Ultimate Sky View Restaurant, will soar 200 meters above the sea and project nearly 27 meters out on both sides from the building's narrow central core. Once again, Wright's throwing down a gauntlet to structural engineer Anthony McCarter. Can he secure this eccentric wing-like structure with no visible means of support?
When Tom first showed it to me, I must admit I thought he was crazy. This room is actually the size of most buildings, and Tom decided that he wanted to take it and stick it outside of the centre of gravity of the supporting structure. So there it was, dangling in the breeze with only the structural engineer to hold it up.
And if the engineers get the calculations wrong, the whole thing could tumble 200 meters to Earth. McCarter finds a solution to the pull of gravity that pushes conventional engineering to new heights. In the concrete core at the back of the building, he casts a series of steel brackets known as embedments. 10 enormous steel girders radiate off them up to 1.6 meters high. These beams form the base of the rigid steel floor. The wing-like exterior can be attached to it, and then the entire restaurant is enclosed in aluminium and glass. This gravity-defying structure will survive winds of close to 160 kilometers an hour. It's an engineering triumph. But they are just 4 years into the 6-year program. No one can afford to take their foot off the gas.
The program was relentless and challenging. 24-hour working, 6 o'clock, site meetings in the morning, every morning.
You live, sleep, breathe the building.
The challenge really was on, can we design it and finish it by the original program?
The Burj Al Arab is due to open in time to celebrate the millennium, just 2 years away. The world's media are watching to see if the hotel will be the masterpiece the Sheikh promises, and if the team can complete it on schedule. The only way to deliver on time is to start the interior decoration long before the exterior is finished. In a temperate climate, this wouldn't be an issue, but humidity in Dubai reaches 100%, and temperatures can soar to a scorching 49 degrees. These conditions simply won't allow the team to fit delicate finishes like gold leaf, silk, and carved wood.
If we'd started to put materials that were susceptible to moisture at that time, they would have just fallen apart.
To make the deadline, the contractors need to air condition this giant building site and bring the temperature down dramatically. The first step is to enclose the building by installing the final wall, Wright's iconic white sail. But it's going to be tough.
When we first proposed the idea of the fabric sail wall, there was a lot of scepticism. People thought that it couldn't be done.
They stretch woven glass fibre sections between huge horizontal beams. The surface is pre-coated with Teflon to resist dirt and sand. The result notches up another first for the Burj, the largest fabric wall anywhere in the world. The reflective properties of the white sail will help keep the temperature down. But the contractors still need to find a way for trucks to enter the building without allowing in the desert heat. The solution is to install a huge airlock. Trucks drive in, the vehicle pauses as the doors close behind it. A second set of doors then open, and the vehicle moves out of the building. The airlock and the sail wall now seal off the building. But cooling a space this large during construction could create a major setback. This unique structure now boasts the world's largest atrium, soaring to an amazing 180 meters. All this warm air can hold far more water vapor than cold air. If they cool this hot, humid environment too quickly, they will create uncontrollable condensation.
We could have had a rain cloud form at the top of the atrium and create massive damage to the interior design.
The only way to avoid rain clouds will cost valuable time. The contractors switch on the giant cooling system and bring the interior temperature down steadily by less than 1 degree a day. Given the schedule, it's painfully slow.
We started to cool the building down in June 1998. By December 98, it was pretty well down to temperature.
At last, the interior decoration can begin. But the hunt for a designer who can create interiors worthy of a sheikh causes further delays. Quan Chu, who's already worked for the Sultan of Brunei, knows exactly what it takes to satisfy royalty. It's great news when she agrees to take on the most luxurious hotel on the planet, with its daunting 202 palatial suites and the 180-meter atrium. But she has just 24 months from design to completion to be ready for the guests booked in for the millennium.
I had a very, very tight program. So what we did was that the entire office, all 50 designers, just dropped everything else. And solidly, we just worked on the Burj Al Arab.
She not only faces a frantic schedule, Sheikh Mohammed is expecting her to amaze the world.
The brief basically asked us to design something that's never been ever designed before, and that will never be designed ever again.
Quan Chu and her team pull out all the stops and begin to produce interiors they hope will match the Sheikh's ambition. But as they struggle to meet the deadline, another more severe problem comes up. The Sheikh wants to offer guests every conceivable electronic gadget in their suite. This new requirement could have dangerous consequences. A new member of the team is suddenly in the hot seat. Electrical engineer Rob Roos faces the biggest challenge of his career.
There was a total redesign or a total change in the interior design. and that imposed overnight almost a 50% increase in the electrical load of the building.
The Sheikh's new plans mean each suite requires an enormous 14 kilowatts. That's 8 times the load of a normal European house for every suite. With 202 suites, that's roughly enough electricity for a town of over 6,000 people. The hotel will have electric curtains throughout, 52,000 lights, most of them on dimmers, and over 5,000 kilometers of electric cable. All these electronics can scramble the waveform of the electric current and create a problem known as harmonic distortion. This can melt the sheathing around live cables and cause a raging fire.
That was a situation which was just totally unacceptable. We had to deal with that.
The people of Las Vegas know just how lethal a hotel fire can be. November 1980. In the city's MGM Grand Hotel, a pair of electrical wires short-circuit. This causes a blaze that wreaks destruction. 85 people perish in this real-life towering inferno, and over 700 are injured. It's one of the worst hotel fires in history, all caused by a simple electrical fault. Roos needs a solution to the fire risk, and fast.
Obviously, the hotel was under construction. There were some fairly heavy deadlines to try and get the hotel finished and opened, and this was a major change.
His response takes electrical engineering to a new level. He devises a harmonic filter system. First, it detects the electronic distortion, then it sends a current that's the mirror image to cancel it. It's called antiphase and works like noise-cancelling headphones. He installs his filters on key floors, and at the point the electricity enters the building. No one has ever attempted a system on this scale before.
This was the largest active filter installation of its kind in a building like this anywhere in the world.
A world-class solution for a world-class megastructure. The team constructing the Burj Al Arab can claim a string of groundbreaking achievements. They build the first artificial island off the coast of Dubai, construct the tallest atrium in the world, enclosed by the largest fabric wall ever built. And with the mast finally in place, this structure, for now at least, is taller than any other hotel on the planet. Now, 5 years into the project, the team reaches an important milestone. The iconic exterior is almost complete, but the interior decoration of the world's most luxurious hotel is seriously behind schedule. This stage has always been a race against time. Now Sheikh Mohammed is about to send the design team into a tailspin. Dubai, April 1999. The world's tallest and most opulent hotel is approaching completion. Everyone is rushing to finish the hotel, ready for the millennium deadline. Interior designer Quan Chu is still operating in overdrive.
Christmas was cancelled, Easter was cancelled, bank holidays were cancelled. We basically made 50, 60-hour weeks.
Her brief from the Sheikh is to shock, to innovate, to amaze the guests with a modern Arab palace. And she delivers in spades with over 24,000 square meters of marble from Italy and Brazil, the equivalent of nearly 3 soccer pitches. Over 8,000 square meters of 22-carat gold leaf give the desired impression of luxury. And she completes the appearance of total indulgence with crystal chandeliers, woven silver and velvet. But for the world's largest atrium, Quan Chu makes a radical decision. She goes minimalist. She lets the complex architecture speak for itself by painting it all white. The interior decoration is almost back on schedule. Then comes the moment of truth. Sheikh Mohammed arrives to examine her work and pass judgment. The man behind the whole project is delighted with the ornate styling of the luxury suites. But that's where the good news ends.
I was summoned and said, when are you finishing off this atrium? I said, well, it's nearly done. Unfortunately, the feedback was no. Where's the color?
The Sheikh completely rejects the white styling of the atrium. It's just too plain.
Not exciting enough, not bright enough, not colorful enough, not rich enough.
Quan Chu has to completely redesign and decorate the tallest atrium in the world in just 6 months.
I was basically living and sleeping in the Burj Al Arab, rushing from area to area.
This is her last chance to get it right, so she sets out to dazzle. She designs a light show to animate the world's tallest fabric wall. Fountains create aqua gymnastics in the lobby. Vast fish tanks welcome visitors as they ride the escalators. And crucially, she transforms the view up the atrium into a rainbow palette of vibrant colors. Will it satisfy Sheikh Mohammed? Everyone's on tenterhooks.
The adrenaline was pumping, sleepless nights basically before opening.
The Sheikh's response is a definitive yes. He's delighted and signs off on the project.
Sheikh Mohammed believes it became almost a 6 to 7 star hotel. And the achievement of his dream, the realization of his dream.
The doors open to the first ultra-rich guests in December 1999, a full month before the millennium. And Sheikh Mohammed comes to watch the final sunset of the century from his magnificent new hotel. Architect Tom Wright and the team have fulfilled the brief. Every part of this iconic structure is extraordinary. In the ground floor restaurant, a team of divers care for 700 exotic fish in this 280 cubic meter tank. The result allows guests to get intimate with sharks while they eat. At the opposite end of the world's tallest hotel, this amazing feat of engineering, the Cantilever restaurant, delivers Tom Wright's vision of dining in the sky. A spectacular combination of fire and water greets you before you even enter the building. Staying here doesn't come cheap. Suites cost up to $28,000 a night. And for guests with that kind of money, there's the helipad weighing 330 tons, projecting off the building over 200 meters above the sea. When it's not being used as a tennis court by Roger Federer and Andre Agassi, it offers a very exclusive way of arriving at possibly the world's most exclusive hotel.
The Burj Al Arab is a project of a lifetime. No other project will ever match this one.
The engineering triumph of creating Dubai's first artificial island has far-reaching effects. It paves the way for a series of enormous schemes, each one more ambitious than the last. From the original Palm Island, which sells out in 3 days, to the World Islands and beyond. The tallest hotel on Earth lays the foundations for a secure future when the oil runs out. And it's now the international symbol for Dubai.
We knew from the start that we had the opportunity to produce something quite startling. And this project, I really think we achieved that.
Sheikh Mohammed's bold gamble has paid off.